Hi everyone. In this video, I'd like to show you how to conduct our investigation into the relationship between the mass of an object and the acceleration it experiences due to gravity. In this first slide, you'll see our aim and the materials you'll require for the lab component of this investigation. Set up the materials as you can see in this image. The two pine blocks will give us the angle for our ramp. These should be kept the same at all times for all trials. This is an example of a controlled variable. We have a Jarrah ramp that will provide our slope and a venue for the marbles to roll down. You can't see it very well in this image, but I've marked 20 centimeter intervals all the way along the Jarrah ramp. At the top we have 0, and then 20, 40, 60, 80, 1 meter, and 1.2 meters. There is also a wooden meter rule that I used to mark off these distances, and I had the added bonus of providing a guide for any marbles that wandered around a bit on the ramp. Was this a good idea? Was it not? You can decide. The electric balance will need a small dish to stop the marbles rolling off when you measure their mass. Remember to tear the balance with the dish on before measuring the marble. We will be using marbles of varying diameter and material, some glass and some of them are lead sinkers. Whenever you're doing an experiment, make sure you note down ideas of what you think works well and what you think doesn't work well, and always be critical in the experiment itself. Ask yourself, does this part of the experiment add to the accuracy or take away from it? After finding the mass of each marble, select your first marble and record the time it takes to roll the first 20 centimeters. Repeat this measurement a further 5 times so that you have 6 repeat trials for that marble at 20 centimeters. Progressively measure the time the marble takes to roll each of the distance intervals. You've done 6 trials at 20 centimeters. Now do 6 trials for that marble at 40 centimeters. 6 trials for that marble at 60 centimeters, 80 centimeters, 1 meter, and 1.2 meters. So you'll have 6 trials for the marble at each of the distance intervals, and you'll do the same for each of the 4 marbles. Now that's a lot of data. You're going to need to put it into a table. Here's the table that I use to hold my data in Excel. Excel has the benefit in that it does the calculations for you. We've got a lot of repeat trials. We have to find the averages for them. Excel does this for you. Now in class, I'll show you how to set this up. But in the meantime, if you need a bit of help, there's the command for making an average in one of the cells. And you can drag that down the cells below it to populate all the cells with the averages of their repeat trials. Now, if you were to graph just the raw data of distance rolled against average times, you would not get a straight line. So this is one of those situations where we have to manipulate the data to get a linear graph. In class we'll talk about why, but for now just accept that the way to manipulate the data is to get the square of the average time. To find the square of the average time, you can input this formula into Excel and it'll do it for you. Excel will also create the graphs for you. In your lab report that you will produce, you're most welcome to use Excel to make the tables and to make the graphs. And you can submit that in your lab report. In the lab validation, you'll have to do all of this by hand. The benefit of using Excel with your graphing is that it will do the following. It will give you a line of best fit, and it will give you a gradient. In your lab validation, you'll have to do this by hand. The gradient will have to be calculated using a rise over run calculation. Excel in your lab report, however, will do it for you. If you look here, in Excel, the gradient or the line of best fit is known as a trend line. And what Excel will do is it will put the equation for the trend line on the graph. Here we see y equals 0.2215x. That means the gradient is equal to 0.2215 meters per second, or if you like, 22.15 centimeters per second. Once you've done tables and graphs for each of the 4 marbles, so that's 4 marbles, 4 tables, 4 graphs, then you'll be able to figure out the accelerations for each of the 4 marbles, and you'll have enough data for the final graph. This is the final graph, where we graph the mass of each marble against the acceleration of each marble. What does this graph reveal? Have a look. The heaviest marble is more than 10 times heavier than the lightest marble. How much does the acceleration change across that massive difference in mass? The gradient of the line of best fit here is almost zero, almost non-existent. The influence that mass has over the acceleration could be considered to be nothing, or if it is there at all, it might be due to some sort of error in our method or some sort of uncontrolled variable. As we finish up the conducting of this experiment, you guys are going to need to do a lab report for me, which will be submitted, and then we will do our lab validation. And this can be discussed more in class. Thank you very much. I hope this was useful.